Hello all. So in this video we'll see few problems on finding the volume using double integral. So here you are asked to find the volume under z equal to 2x plus y over the rectangle r equal to set of all xy where 3 less than or equal to x less than or equal to 5 and 1 less than or equal to y less than or equal to 2. So we'll see how to evaluate the volume using double integral. So this is how the surface will look like. So here we have the surface z equal to 2x plus y and the rectangular region will be in the xy plane. So we need to find the volume. By the formula for volume as a double integral, volume will be given by double integral over r f of xy. So you can choose any order of integration. So let me take dx dy. You can also use dy dx. So this will be equal to double integral. So substituting for f of xy, we'll get 2x plus y dx dy, and here x varies from 3 to 5 and y varies from 1 to 2. So upon integrating this, we'll get integral 1 to 2. So first we need to integrate with respect to x. So integral of 2x will be 2x square by 2. So which will give us x square plus integral of y will be considered as a constant. Then the integral will be yx. Then upon applying the limits, so the limit will be from 3 to 5 dy. So that will be equal to integral 1 to 2. So we have to substitute the value for x. So 5 square, that will be 25 plus 5y minus, then we have 3 square which is 9 plus 3y dy. So that will be equal to integral 1 to 2. So 25 minus 9, we will have 16. So 16. Then 5y minus 3y, so which will be plus 2y dy. So we have to evaluate now integral 1 to 2, 16 plus 2y dy. So upon integrating with respect to y, we will get 16y. And integral of 2y will be y square. Again we have to apply the limits from 1 to 2. So upon applying the limit, so 16 to 2, that will be 32 plus 2 square is 4 minus when y is equal to 1, we will get 16 plus 1. So the required volume will be equal to 19. So the next problem is you have to find the volume in the first octant of the solid enclosed by the surface z equal to x square and the planes x equal to 0, x equal to 2, y equal to 3, y equal to 0 and z equal to 0. The surface will look something like this. Okay, so the blue surface is z equal to x square, and then we know the planes x equal to 0 and y equal to 0. Now the green plane is the plane x equal to 2 and the red plane denotes y equal to 2. So we need to find the area enclosed by these two planes together with the planes x equal to 0, y equal to 0 and z equal to 0. So the portion will be this portion in the first octant. So we have to find the volume in the first octant under the surface z equal to x square. So our f of xy will be here x square, and x will vary from x equal to 0 to x equal to 2, and y will vary from y equal to 0 to y equal to 3. So that is how the volume enclosed will look like. So on the xy plane, the rectangular region we have will be 0 less than or equal to x less than or equal to 2, and 0 less than or equal to y less than or equal to 3. So the surface will be z equal to x square. So replace f of xy by x square in the formula for volume. And here I am choosing the order dy dx. You can take it to be dx dy also. So if I take dy dx, so I have to give the limits of y here, which is from 0 to 3, and this will be the limits for x, which is from 0 to 2. Now first we have to integrate with respect to y. So x square will be considered as a constant. So integral of x square will be x square y, applying the limits from 0 to 3. So this can be simplified to 3x square. So now this will be an integral with respect to x. Upon integrating, we will get x cube from 0 to 2, and on applying the limits, we will get the required volume as 8. Okay, now we'll see the third problem. So in third problem, we have to find the volume in the first octant bounded by the coordinate planes, the plane y equal to 4, and the plane x by 3 plus z by 5 equal to 1. So we have to find the volume in the first octant enclosed by these surfaces. Now the region or the enclosed volume will look like this. So the blue surface is x by 3 plus z by 5 equal to 1. And the green plane denotes the plane y equal to 4, and the purple one denotes y equal to 0. So as you can see, the plane x by 3 plus z by 5 equal to 1 will intersect the xy plane. So when that intersects the xy plane, so it will form a rectangular region. So it will form a rectangular region which is bounded by y equal to 0, y equal to 4, and x equal to 0, and x equal to 3. Now x equal to 3 is obtained by plane x x by 3 plus z by 5 equal to 1 എന്ന് പറയുന്ന plane xy പ്ലെയിനുമായിട്ട് intersect ചെയ്യുമ്പോൾ on the xy plane z ന്റെ value 0 ആയിരിക്കും. Z ന്റെ value 0 ആകുമ്പോൾ from this equation z will be equal to 5 minus 5x by 3. Z equal to 0 വരുമ്പോൾ ഇവിടെ z equal to 0 substitute ചെയ്യുക. അപ്പോൾ we will get 5 minus 5x by 3 equal to 0. Cross multiplying with 3 and equating it to 0. നമുക്ക് 3 വെച്ച് cross multiply ചെയ്യുമ്പോൾ on numerator we will get 15 minus 5x by 3 equating it to 0. So we will get 15 minus 5x equal to 3. So upon simplifying we will get x equal to 3. So in this graph, this is the portion of the plane x by 3 plus z by 5 equal to 1. Then we have the planes y equal to 0 and y equal to 4, and ഈ surface xy plane ne intersect ചെയ്യുമ്പോൾ we'll get the line അല്ല plane intersect ചെയ്യുന്ന line x equal to 3 ആയിരിക്കും. So along there we'll have the plane x equal to 3 and x equal to 0. അപ്പോൾ അത് വെച്ച് ബൗണ്ട് ചെയ്യുന്ന റീജിയൻ്റെ വോളിയം ആണ് നമുക്ക് കണ്ടുപിടിക്കേണ്ടത്. സോ here f of xy will be ഈ ഇക്വേഷൻ നിന്ന് z വാല്യൂ കണ്ടുപിടിക്കണം. So that will be our f of xy. From this equation z will be 5 minus 5x by 3. So our f of xy will be 5 minus 5x by 3. Now upon substituting it into the volume formula, this will be the formula, and the rectangular region will be, so y will vary from 0 to 4, x will vary from 0 to 3. So I am using the order dy dx. So upon integrating with respect to y, first y വെച്ച് ചെയ്യുമ്പോൾ x will be considered as constant. അപ്പോൾ 5 minus 5x by 3 constant ആയിരിക്കും. So the integral will be 5 minus 5x by 3 times y. Apply the limits from 0 to 4. So we will get 4 into 5 minus 5x by 3. And now again integrate with respect to x. Upon integrating with respect to x, we will get 4 into 5x minus 5 by 3 x square by 2. Applying the limit from 0 to 3 and consequently simplify cheya. So we will get the required volume to be 30. Now we will see the last type of problem, that is to find the average value or mean value of a continuous function over a rectangle R. If we are given a continuous function f of xy defined over a rectangle R, so I'll take the rectangle to be AB cross CD. So we will have A less than or equal to x less than or equal to B, and C less than or equal to y less than or equal to D. Then by average value or mean value of a continuous function, we mean that is 1 by area of R, double integral over R, f of xy dA. അതാണ് f of xy യുടെ average value അല്ലെങ്കിൽ mean value എന്ന് നമ്മൾ പറയുന്നു. 1 by area of R into this volume integral. അപ്പോൾ റെക്ടാങ്കിളിൻ്റെ ഡയമെൻഷൻസ് x വേരി ചെയ്യുന്ന a to b ആണ്, y വേരി ചെയ്യുന്നത് c to d ആണ്. So the area of the rectangle will be b minus a into d minus c. So f average will be given by this. So we will see an example. So we are asked to find the average value of f of xy equal to xy square over the rectangle 0, 8 cross 0, 6. അപ്പോൾ xന്റെ value 0 to 8 വരെയാണ്, and y varies from 0 to 6. So area will be given by 8 minus 0 into 6 minus 0. So that will be 8 into 6, which is 48. So by the average value into formula വെച്ചിട്ട് f average will be 1 by area. അപ്പോൾ 1 by 48 വരും. Integral over R f of xy dA വരും. Now I am choosing the order dy dx. അപ്പോൾ y യുടെ variation 0 to 6 ആണ്. That will be the limit of the inside integral, and the outside integral is with respect to x 0 to 8 വരും. അപ്പോൾ with respect to y ആദ്യം integrate ചെയ്യുമ്പം y cube by 3 limit apply ചെയ്യുക 0 to 6 വരെ. അപ്പോൾ we will get 1 by 48 integral 0 to 8 216 by 3 x dx. Now again we have to integrate with respect to x. So constants വെളിയിലെടുക്കുക, simplify ചെയ്യുമ്പോൾ we will get 3 by 2 integral 0 to 8 x dx. Again the integral is x square by 2. Apply the limits from 0 to 8. So on simplifying we will get the average value to be 48. So with this we have come to the end of our course. ഇത്രയായിരുന്നു ബാക്കിയുണ്ടായിരുന്ന പ്രോബ്ലംസ്. ഒന്ന് വോളിയം ആസ് എ ഡബിൾ ഇൻ്റഗ്രൽ കണ്ടുപിടിക്കുന്ന, വേർഡ് പ്രോബ്ലംസ് വന്നാൽ വോളിയം കണ്ടുപിടിക്കുന്നത്, ആൻഡ് വി ഫൈൻഡ് ദ വോളിയം ഓവർ റെക്ടാങ്കുലർ റീജിയൻ ഓൺലി. അതുപോലെ എഫ് ഓഫ് എക്സ് വൈ എന്ന് പറയുന്ന ഒരു ഫംഗ്ഷൻ റെക്ടാങ്കുലർ റീജിയനിൽ ഡിഫൈൻ ചെയ്തിട്ടുണ്ടെങ്കിൽ, കണ്ടിന്യൂസ് ഫംഗ്ഷൻ ഓവർ എ റെക്ടാങ്കുലർ റീജിയൻ തന്നിട്ടുണ്ടെങ്കിൽ അതിൻ്റെ ആവറേജ് വാല്യൂ എങ്ങനെയാണ് കണ്ടുപിടിക്കുന്നത് എന്നുള്ളത്. താങ്ക് യു.